I would like to welcome everyone to our product showcase presentation, Front Loaded, dealing with specs, U-values, acoustics, and the New York City DOP submission process. It's organized by New York Passive House and presented by Zola. I would like to thank Zola for your support throughout the years. You are a very strong partner to us and makes events such as today possible. It is my pleasure to introduce Sam McAfee, who is in charge of Zola's New York City client support and market development, and also is an expert in Passive House design and Passive House Windows. With that said, I would like to hand it over to Sam.
Thanks, Andreas. Good morning, everyone, and thanks for joining us. We talked about some subject matter that we thought we should present to New York Passive House. Often it's about windows and doors and performance and operation and budget. But what we're seeing is more and more that because specifically New York City DOB has an online submission process for their paperwork, that the rigor of the front end of loading and getting the specifications and paperwork for projects has gone up for architects and owners. So we wanted to cover some of the confusion and pitfalls, as well as support and clear up some of that front end confusion, because with the increasing, say, U values and requirements for that, with fewer windows able to meet that, with Passive House in the mix and the different testing criteria, that it actually has gotten to be quite confusing for most people. So we put together a presentation to help clear up some things when it comes to U values, dealing with some of the acoustic, Little-e acoustic, and then also questions about child falls that we're getting as well. U values, Little-e acoustics, child fall requirements, specifically for New York City DOB, and confusion. So first thing I wanted to cover is some of the testing criteria that are used in fenestration for North America, Europe, and Passive House. And I kind of just wanted to lay a base for like the criteria. So there's, of course, this comes from confusion. So in North America, we're based on ASTM testing standards, which is the American Society Testing Materials. And on top of that, we have NFRC that uses the ASTM and AMAA that uses the ASTM. The windows that we import out of Europe are, of course, initially based in the ISO system, which is like a parallel testing system to ASTM, and they're used CE mark for all criteria that are related instead of NFRC and AMAA. And then, of course, Passive House has developed a hybrid system using their own testing temperature criterias and some different methods, and it all is based on ISO as well. One of the key components of this is that actually in Europe, the ISO testing criteria for windows and doors is really component based. So it's frame, glass, spacer, install, and all of the componentry related to that. Where in North America, NFRC and AMAA is predominantly based on in situ testing of actual windows as installed into a test criteria. So they test specific actual real windows. As of late, over the last 10 years or so, last 5 years, they've been transitioning to component based, but they're not there. So all windows in NFRC are really whole window tests in place. So you don't have the frame and the glass values separate. And you don't have the install and all that kind of stuff. So with that, there is some confusion that happens with our specifications, because a lot of our windows both have NFRC and CE value U values that come to you. This is an example of our triple glazed UPVC. On the left is NFRC, which does an in situ whole window fixed, whole window operable, and then on the right is the component based CE value out of Europe with a U value for the UW of 0.8. So part of the confusion is that people think that they convert back and forth between U values, between NFRC and CE, and actually get numbers that are comparable. And if you do that for this single window product, you'll see that actually your conversion is from CE is 6.6% better for the fixed and 17% better than the operable. And when you're talking about U values and specs and thresholds, that's a massive difference. So if you're shopping for windows and trying to set a threshold, and and you're doing it for New York City, and you have code that's based on NFRC, and then you're taking the CE value and trying to convert it and see if you can get it. Yeah, in some cases you're going to get there, but it's only because the CE value is better. lot of people ask us why that's the question. And the reason is because actually the NFRC test criteria is based in imperial units, and the CE values are based in metric. So the NFRC test temperature, the main criteria that actually does this is the test temperature. The NFRC test temperature is 0 degrees Fahrenheit, and the CE value test temperature is 0 degrees Celsius. So there is a 32-degree difference between the test criteria of these two methodologies. And so what you get is a less rigorous, if you want to call it that, because the temperature is 32 degrees Fahrenheit higher in the CE value test. So therefore the same window appears better. And you can see that it actually appears better, especially for the operable portion as compared to the fixed. Do note that NFRC to CE are not comparable, and it causes confusion, and you need to know which place to use it. I'm going to go back to the previous slide and explain that. So if you are applying these type of criteria to DOB's paper submission, then you're going to be in the North American testing ASTM-based NFRC. If you're going to be in the European, or if you're going to use the Passive House, then Passive House Germany is going to be asking more for the CE values and the ISO values out of Europe, because they're going to be asking for the component-based metrics, which the NFRC values don't provide. One thing that's not on here is, of course, Passive House US. And Passive House US has aligned themselves with the NFRC and the North American, so there's no confusion. I could just say Passive House US is over in that column. So if you're actually applying your testing procedure to the DOB for paperwork, hitting your minimums U value, then you're going to be using the left column. And if you're going to be doing Passive House, you're going to be using the right two columns. So you might be actually needing two different test criteria for projects if you're doing both. The whole genesis of this entire little U-value conversation came from the fact that we've been seeing in the Northeast some specs coming from asking for a whole window U-value of 0.21 or better. I should back up. They've been asking for a U-value of 0.21 or better. And this has actually caused some confusion and taken some time to unwind the knot for those projects. First off, 0.21 sits squarely between two window products. And secondly, what's the units on this? I can see that it's 0.21, so it's going to be a metric-based BTU, because 0.21 and ISO or in Europe, that's not realistic. And the third part is, are they asking for NFRC or are they asking for CE converted? Well, I can tell based on 0.21 that they're actually converting the CE value of a dual glazed window, because when you ask for a 0.21 or better, it's a little confusing because the actual triple glazed version is way better than 0.21. And actually 0.21 is the conversion of the dual glazed CE value for the whole window. I'm just going to pause with that for a second, because that is actually really confusing. So really what we're finding is that people are using European windows, converting the CE values and asking for specs from that CE value from the dual glaze. Now in Passive House realm, dual glaze is not appropriate for the Northeast, especially New York City, when it comes to performance. But what we're seeing is passive measures and people trying to just build better right off the bat, trying to hit New York City thresholds for increased performance. That points them to actually kind of looking at values, but if you're shopping European windows and converting the BTUs that they give you, then you're going to get a value that actually is out of alignment with what you're going to need to submit to the New York City DOB for code approval. I don't even know if the DOB would even recognize that this error is being had because of the complexity of it, but the truth is you should really be looking at NFRC values if they're available for New York City, and if they're not, then you should actually be discounting the CE values. But most importantly, you should actually be stating where the value comes from. And nobody ever does that. If you give us a 0.27 BTU, you should kind of kindly say that that's an NFRC value. Or if you're giving us a 0.21, you should say that that's a CE value, because 0.21 CE is actually equivalent to the 0.27 fixed NFRC. That was a lot, that was fast, but this is a big presentation and I want to allow for lots of discussion after the fact. So acoustic testing, voluntary versus required, and what is Little-e. So for those who haven't dealt with Little-e projects and acoustic requirements that are actually required in New York City, Little-e is the environmental tag that gets put on certain properties for things that need either sound or environmental remediation. So some projects have been identified as having dirty soil that has the distillates in it. So all this soil has to be scraped off the top 2 feet for environmental concerns. That gets a Little-e requirement. Or it's in a flood zone, so it gets a Little-e requirement because it needs additional remediation to deal with the situation there. But especially in New York City, acoustic. There are certain corridors and certain areas of the city that are just loud. And if you're going to build residential, then you are required to have a maximum acoustic threshold inside the building once the building's completed. I believe it's 43 decibels RW. So that means if your building has a tag Little-e and has a required acoustic threshold that it has to hit, that you have to buy components and build walls on the exterior that stop that sound and maintain that quiet interior. A couple of those are like along the BQE, along the major avenues, along the West Side Highway. There's lots of Little-e channels through the city that they actually tag buildings with. So what are the different components of acoustic when we're talking about it? Here's a quick definition, an outline of what the acoustic like landscape is when we're talking words. A lot of people historically have done sound in the past, come to us with STC requests. Technically, OITC is for exterior walls because it deals with the lower frequencies of like trucks rumbling and like trains and all those kind of things. The higher frequencies are more like whistles and people screaming and kids and talking through walls. And then a quick definition of the frequencies versus amplitude for those who don't understand it. Frequency is the wavelength of the sound. High-pitched sounds are closer together, low-pitched sounds are longer. And the decibel is how loud it is. So how you can have a frequency, but if it's really loud, then it's like pronounced. And so you can have a very loud whistle or a very loud rumble, or you can have a quiet whistle and quiet rumble. So the two pieces are the frequency and the decibels. And then finally, the RW is kind of the weighted sound reduction index. This gets applied to what materials are. So when a window gets acoustically rated, it gets an RW, which is kind of a single number that conveys how many decibels can be reduced by that product in order to make it fit into the window, make it fit into the situation. So if you have an exterior situation with helicopters, and I'll point to this graph here at the top, that's 100 decibels, and you need to maintain a 43 decibel interior environment, then you actually have a situation where you have to reduce by 57 decibels. So all of the wall, the window, and every single component has to meet a minimum of 57 decibel RW, a reduction weighted index of 57 decibel. That's quite large. So hopefully you're not building it adjacent to a helicopter landing pad. How do we do this? What are the components of glass to handle the sound and the shutting down of it? The main component is that the outside piece of glass is a laminated piece of glass that has a interior plastic meant to shut down sound and not transfer it. The other parts are for triple is to have asymmetrical spacers. If there's two chambers, then you can actually have spacers of different widths. One can be 16, one can be 18, and one can be 14 to get your widths. And when you do asymmetrical chamber sizes, it disrupts the wavelength transfer and actually causes further sound reduction. And another trick is actually you can have different sizes of glass. So the outer glass can be thick, the inner glass can be a 4 millimeter, and then the interior glass can be a 6 millimeter, and that also then reduces. So different widths and different densities, and the PVB insert, and then the gas, and so all of those type of components, as well as the the low emissive, the low E film, actually also reduces sound a little bit. But all those components done in different combinations create an acoustic level of glass that actually shuts it down. For the very, very loud and the very, very extremely large decibel ones, you might need 2 acoustic glass pieces. And do note that when you start adding acoustic glass, the performance starts to go down because you can only have a glass of a certain dimension fit into a frame, and sometimes that glass gets so huge that you can't even make it. Because of that, a lot of people think that triple glazed glass is always better than dual glazed glass when it comes to acoustic, and it actually is the opposite. We can make higher acoustic grade glass in dual because we have more space to put in these very thick pieces of glass that can shut down more and more sound. We only have so much space we can take up with a triple piece of glass because it's already so big that at a certain point we just can't put in thicker glass. We can't go to the most acoustically dampening glass available. Airborne test on a window. This is a triple. Was this a triple? Yeah, it looks like a triple. 2 air spaces. This is a triple UPVC that we had tested. And I just want to show you what the test looks like. You can see the Hertz frequencies at the bottom that they're testing, and kind of going through and checking at each channel how much stoppage is taking place by this window. This is an actual in-place whole window with frame. And then they go, and this one is from 80 to over 400. So it looks like the black line is on the OITC, but the red line is on the 125 to 4, which looks like it's the STC. And so both of those numbers are now represented down at the bottom as a whole window offset normalized to give you a 42 for the STC and a 35 for the OITC. So even though the tests happen at the same time, you can see that the numbers are going to be different because they actually take into account different acoustic ranges. So the OITC is lower because the lower performance of this window at the lower part of the range. An interesting thing about the single number result is that there are, let's take a look at the OITC on this, it's 35. So 35, like if you're looking for a 35 acoustic stoppage at the higher frequency range, I'm going to go back to the soundboard here, at the breathing, the whisper, the rustling leaves, the refrigerators, those things are actually quiet, but these are actually about decibel ranges. We're looking at things that are like high pitch, car horns, squealing train track wheels for the elevated F line with the train like squeaking and making tons of noise as it goes by. Those are in the higher frequencies and stuff like that. If you look at it and think, hey, it's only going to stop 35 decibels in the higher frequency, that's not actually true. It's actually up in the mid 40s for those type of things. And it actually keeps going up and up. In fact, if you look at the 4,500, it's actually above 50. So the single number OITC does not always represent the best glass for your situation. If you know you need to target a certain type of sound, you could actually go and look at the glass reports and see that there's some glass that has a lower single number OITC, but actually performs better at the higher Hertz range, which you might be targeting. We found this out multiple times, and in fact, sometimes you can reduce the cost of glass and actually still target it with a lower single number OITC. This is I just wrote this. You can read it. We literally have thousands of assembly combinations because the spacers and glass and dual and triple. It's the acoustic glass. There's so many different ones with different cores. We have so many combinations, and we have so many frames that there's no way we're going to physically put all glass in all frames and test it. It's just not possible. But what we found is that quality frames don't reduce the glass's testing ability. We can actually say that if a glass has a 35 OITC, that our higher performing frames will actually hold the glass's sound acoustics. When I say higher performing frames, I'm really talking about the woods, the thermoclads, the UPVCs, and the insulated thermoplast clads. When it comes to the aluminum windows, it's a harder, the insulated value is a little bit lower. There might be a point or two reduction in the aluminum. We can run an analysis of all of our previous tests for the acoustics we've run and actually see if it matches the glass. But my guess is that it's a 1-point reduction on aluminum, but a 0-point reduction on all the higher performing frames. And so how do you deal with the city and Little-e, which is very early in the DOB filing process, when you're just kind of like specifying the window and you probably don't have a window that meets high performance, is your frame, and also meets the acoustic for that situation. So our solution has been to write a letter stating that, in fact, we provide the performance sheet for the glass. Say the glass is a 35 or a 40 or a 36 as needed for that situation, and that our frame maintains this glass's performance. And so our window frame plus glass will be 35, because ultimately it does hold. We've done tests, we have it, we see it, we can go back and forth and see it has integrated. And that ultimately the final test is that they want to then stand inside the room at the end of construction, hold the sound monitor, and know that actually it's maintaining, I believe, the 43 decibel threshold for the RW acoustic inside, and that all of the components of the wall, including the joist, the penetration, the wall, the assembly, the insulation, the window install, all the components, including all vents, actually as a unit maintain this threshold. So that's how we navigate Little-e. And that's how we provide paperwork to our clients who have Little-e dilemmas, and how we actually solve it and get it moving as quick as possible. So if you do have that problem, just come to us. We'll get it unstuck real quick. Child falls. This isn't DOB, this is DOH, and I wanted to talk about the landscape of child falls. So child falls is a usage, not a code. You can have the same construction and building and all of the same. The question is, does your project fall under the Department of Health Child Falls Inspection Protocol? And for moderate to low income rentals of a certain size or higher, the answer is yes. Number of rentals are higher, the answer is yes. For condo buildings and for sale units, the answer is no, because those are single family residences. They're not going to be inspected by DOH. But at any point, if that condo during construction converts to rentals that are under the purview of DOH inspections, and all of a sudden it is under DOH and it has to be installed, which is a really confusing thing. We've had that on a couple projects that it's actually converted right in the middle, especially as the economy kind of like money kind of goes and rentals become better than sales, and it goes back and forth. But solving the DOH child falls requirement for inspection is not easy. So here's a slide for non-DOH projects. These are the typical things that we provide for people who are looking to limit the swing or operability so no kid can get out. We key out, the first one is we key out the turn and provide only a tilt function. So a key is always required to actually get it into the turn function. And then the second one is to provide a swing limiter, either a releasable one for fire egress or one that is actually not releasable or easily releasable. It is releasable, but with a tool. And that limits the swing to 4-inch. Those are the two solutions. Neither of those solutions, or none of the three of those solutions actually work for DOH. So surprise, surprise. The ones that do work for DOH are child bars. Have nothing to do with the window, have mounting screws, or separate from it. That's why you see them all over the city buildings. Child bars, child bars, child bars. The cheapest, easiest, and most effective post-occupancy change, nothing to do with the window solution. If it's part of the window, then it's going to be the tamper-proof, high quality. It's because your typical swing limiter is not strong enough to actually pass the DOH pull test. I think it's 150 pounds. So you got to think about a person like bench pressing the door or the window, to like actually cause it to fail so they can open it wider. Like they want to prevent this kind of like, in a sense, they want to make it prison proof. So with that, there are some windows that we can't get 150 worth of connection. Like getting the correct screw to hold in 150 pounds of force on a UPVC window is quite difficult. So DOH actually has very limited solutions. They won't allow post-market. They won't allow anything that has an occupant override that isn't permanent, and they won't allow anything that ships without hardware because the hardware has to be tamper-proof and you can't remove it. So all screws have to be one-way screws, and they have to be tested that they hold to the 150. With that means that tilt windows fail. The built-in tilt mechanism on a tilt turn window actually does not meet that criteria. You can see the little components here. It actually rips apart at the 150 weight threshold, and then therefore it can't be used. So you're gonna be forced with a turn only window, and more importantly, you can't put an additional piece of hardware on the tilt function to help reinforce this, because there's no there's no room for real estate. You can see how big this piece of hardware is at the top, and there's no other place or no other space for an additional. So if you're going to have a child falls and you have tilt turn and you convert your project, that actually then requires DOH, and all of a sudden you have tilt everywhere. The tilt windows are actually now non-functional. They actually won't meet the DOH. So it's very important to establish and stick to really early the piece of the tilt or the functionality if you have a DOH requirement for child falls. So child falls, what's allowed? Child bars, always easy. Swing only windows with robust swing limiter. It has to have a label, and the label has to be stamped and unremovable. It has to have screws that are tested as part of it and provide with it one-way install, so they can never be removed. Very permanent, and soft frame materials that like UPVC and some softwoods may not ever be able to get DOH approval because there's no way to get a 150-pound screw in there to not really sit. It's 2 screws. It's very limited. So, and then what's not allowed is the tilt functionality. Aftermarket solutions aren't tested. Things that aren't DOH approved, and there is no post-market approved swing limiter that can be installed on any window. That's not how the DOH child falls works. They need the whole thing tested together, and the system is frame plus connection screws plus swing limiter arm that is robust for this test. That is a mouthful. I did it in about 25 minutes. I didn't want to do it in an hour. And now I think I'm at the end here. That's the summary. And I want to open this up to questions and keep it short and sweet. I want to keep the presentation short and sweet to open it up to questions, because I know a lot of people are going to like have some specificity, and I might even get some corrections from some of you. Some of you might actually say, my experience was a little bit different. And as you know, the DOH, Department of Building, DOB, and the DOH are very slippery and sometimes do things in a couple different ways. So with that, I'm going to open it up to questions and discussion, and thanks for your time.
Thanks, Sam, for the presentation. Can you explain a little bit more that fact with the the hardware for a tilt and turn window? So you're saying if it's an what is it called, DOH requirement for a multifamily high-rise building, you wouldn't be able to do a European tilt and turn?
You would have to do turn only with a DOH pre-tested approved swing limiter, and you'd have to remove, because the tilt functionality that of the hardware in Europe does not meet the 150 test. Somebody can get up on that window and with 150 pounds of force can make this arm fail and force it open. So yeah, that's why you're seeing people come into the market. They have tilt turns, they're doing the larger buildings, and then they go, whoops, it's a DOH building, and now I can't do a tilt function. It has to be turn only with actually a reinforced, very robust swing arm. Not your typical swing arm. It's actually a much higher quality swing arm.
Okay, understood. So there are a couple of questions here. Caleb asks.
Hey, Caleb.
Hey, Caleb. And we can also, we are not that many people. We could also allow people to unmute themselves. But Caleb asks if the ISO standard doesn't deal with solar heat gain coefficients and visible transmittance.
All right. Yeah, that's a good question. I'm going to go back here. All we're giving here is SHGC and VT for that. But you see the UF, UG, UW. It's a component-based. It's a component-based system, so it does give that, but it only gives that for the glass. So when you have SHGC or VT, it's giving you the VT for the glass and the VT and SHGC for the glass. NFRC is whole number, so the SHGC is glass plus frame, and the VT is glass plus frame. That's very weird to me, that you're talking visual transmittance and your number is literally accounting for the opaque frame that's also included in the NFRC number. But that's the way they test it. They test the entire unit installed, and the number is the number. That's what they're pulling. The component-based system, we're going to give you the glass SHGC for CE, and we're going to give you the glass VT, visual transmittance for CE. Does that make sense, Caleb?
And Caleb, you had another question here regarding the testing.
Oh, do you guys do you test with the NFRC or do a conversion? Basically a cheat sheet for architects, so that we can actually just put that into our compliance.
Yeah, so what I'm showing you is screen grabs from our spec sheet. So,
Okay.
so these are literally on our spec sheet for these products, and the NFRC value and the C value both appear on a lot of things. If we have the NFRC, we provide it. We do not have NFRC for all products. We have NFRC for the main products used in residential construction. We also, of course, have higher performing products which don't have NFRC, which are very, passive house focused. We don't have NFRC value for the passive house stuff. Another difficult thing about NFRC, I'll just throw out, is two things. Another thing about NFRC I want to throw out is that NFRC likes every glass and every frame combo to get tested. So if you deal with somebody like Marvin, they have about 15,000 NFRC tested windows because of every little combo they do. They just keep testing. They have in-house, they just test it. We're not going to go do every glass and every frame. This is tested for our standard product, to be perfectly honest, which is like for our glass is going to be a 444 with a window at a certain value, which is like 60 inches high by whatever, 34 inches wide, whatever their testing size is with our standard glass. We, of course, have dozens of different pieces of glass. So larger windows are going to have tempered and a 6 mil, and sometimes we might throw in a lamy for structural, and then we have the acoustic. All of those glass and the frame combinations, those don't specifically have NFRC testing values. I want to be very clear. It's very expensive. It makes no sense for us. So there's kind of a balance between doing NFRC and not. Of course, we have CE values for absolutely every product. And even our aluminum line, we can produce the CE performance values and components for every size window that you price with us. We can generate the CE value for that specific window. It's simulated through software, and we can give you the actual windows as size UW, not just the estimated NFRC 60 by 30, whatever size. So the other part, which I was gonna say is, oh yeah, so for the SHGC of our default glass and the CE value is at 0.5. That actually converts to NFRC when you include the frame of approximately 0.38, 0.39. Does that make sense, Caleb? Like if I go and take a calculation and do the standard size NFRC frame and use a 0.5 CE glass and account for the frame, the end result is I get an NFRC equivalent of 0.39. Just so you're aware, the conversion of a 0.5 glass SHGC converts to a 0.39 if it were in the NFRC, 0.39, 0.38.
Yeah, got it.
Because when I account for the frame and do the math and subtract out that frame at that same dimension for the NFRC, it turns into a 0.3938. So people are asking, like, you gave us a 0.5 glass, but I need a 0.38 glass. And I'm like, yes, this is actually a 0.38 glass when you actually convert it to NFRC and account for the blinking out of the frame, the opacity of the frame at that dimension.
Oh, energy code, of course, calls for, since you were on the solar heat gain coefficient, what is it now? It had been a 0.4. I can't remember what it is for the new energy code. I think they've dropped it like another
0.38. We're seeing a lot of 0.38. Maybe that's what it is.
I suppose if one were to do a full ASHRAE 90.1 analysis, you could do a higher solar heat gain coefficients and still meet the code. But I mean, one of the things that we do in passive house is we figure out like how much heat gain we actually need so we don't overheat in the summertime or even in the winter time. So have you run into, other than have you been able to use higher solar heat gain coefficients in projects for architects that haven't actually run like the ASHRAE 90.1 calculations?
Well, the passive house is, of course, component-based, and the CE values allow us to give you the component-based math to do that. We've done in some cases, I don't know if that's exactly, we've done in some cases different SHGC for different facades so that you can actually program it. Actually, there was a case where we needed to increase the U value of some of our glass doors to meet the passive house threshold. And so there was a request for Krypton, but we're no longer, we do not currently have Krypton available, so we can't boost our doors that way. Heads up, doors do perform less, but we can provide you a door-to-door kind of like criteria. But when it comes to the SHGC and actually the programmatic, there's larger pieces of glass, there's smaller pieces of glass. The SHGC on the NFRC value is not accurate to the actual size of the window. So if you have windows that are bigger than whatever it is, I think it's 60 by 36 or 60 by 34 is the test criteria size. If you have windows bigger than that, then you're going to have more glass, less frame. If you're running models and actually using component based, then you're going to be way more accurate. And you can program in, and you can tweak the SHGC on the west facade if it's facing that way, and you could account for shadows for surrounding buildings if you're in the city, and you could do reflections on the back of the building if it's north facing, and deal with that kind of passive house stuff, right? You're laughing. Yeah, been there.
Yeah.
Reflective light off a skyscraper coming in the back of the building, being accounted for a heat gain in the back. You can do those kind of things, and yeah, you can program it in with a 0.5 glass or a 0.62 glass or a 0.26 glass. We have 3 different glasses, so you can go up and down. Does that help? I know it's not exactly ASHRAE 90, but
I know it's just, it's just with the myriads of codes and compliance tools and like running like PHPP in the first place. Kind of what you always want to do is like kind of the minimum compliance for the DOB.
We have a cheat sheet. We have a cheat sheet. And we have tons of data. It's in the background. Just ask, we'll give it to you.
Since we were talking about all of this with the different glazings and the fact that you don't have Krypton, was like, my question was, have you guys been looking at vacuum insulated glazing?
It has to do with longevity, price, and we would have to change our frames to accommodate the thinner glass. Like, I want to say it a different way. Just because the glass is thinner at a higher performance, what about the insulative values of the frame, which is already the weak spot? I mean, in a sense, does it stay vacuumed? Is the glass quality there? Is anybody even producing it so we can actually use it consistently? It's really...
There's been a lot of progress in it from what I've been seeing, and that the longevity has gone up quite a bit, but I don't know many people who have actually been using it. So why I thought, like, I'd ask, like, you guys researching it, how, like, because it's, think about it, it's like a third less, it's, 53rd less material, right, to potentially get the same insulated value. So,
I think it's going to be this equation. Because it's thin, it might fit into a US window better. When you see the US manufacturers using it and offering it at scale, we'll also be doing that, because it's probably a US solution first.
Yeah, I want to take a couple of other questions as well, so give everyone a chance. Thanks, Caleb. So Dennis asks, will an affixed window insulator's attachments be evaluated the same as new windows?
Okay, well, the attachment to the actual building installation value is a passive house assessment. It has to do with, we of course provide metal clips, but how you use them and how you protect them and how you stop the thermal transfer and install detail, that's over in the passive house realm. We certainly could help with it, but we don't draw that. And every project's a little bit different. Attachments, affixed attachment. I don't know if there's anything within the window that I can think of that question might be attached, that might be focused on. But the window itself is, of course, we can provide therm and all that kind of cross-section stuff, no problem. So
there's a question if you guys have rabbit family cat details for your windows.
Some Revit, some model, some objects, yes, in some cases, especially some of the new ones, and we're getting more and more. I think a lot of our background stuff is done in Revit, even though you get CAD from us or DWGs from our Revit. But yeah, if there's a specific product line that you need Revit for, definitely ask and I'll see if it's available.
And is it true for ArchiCAD as well, or?
I don't know. We're running on Revit, so it's whatever they can produce. I'm not a Revit person, so it's like that might be a little bit above.
So I don't know if you answered that question about the testing at which temperature between NFRC and the CE labels. But
yeah. So
I think you answered that one, right?
Yeah. So it's 0 and 0. 0 Fahrenheit for North America, 0 Celsius for Europe. That is at the core of why the temperature differential is, the performance differential is what it is. And CE test temp is 9 degrees. C might not be 0. I see their question. I'm trying to track a lot of data, so I might have that off. But I do know that it's a dramatic difference between the two. And some tests are to 9 and some are to 0. So I might be confused a couple different tests.
And so Drake asks, why don't you guys don't get the NFRC testing done for your Windows? Or
Sorry, the backup on, I read the question here, and there's a second part of the question, but why, with the temperature, it says, but why is CE then more stringent if the testing is higher? So CE is more stringent in the sense that it does component-based and has a higher number of requirements, acoustic, water tightness. There's less voluntary requirements. Okay, so there's a lot more criteria that we have access to, which is why high performance construction developed in Europe first, is because you can actually say, I want to mix this frame with that glass, with this gasket and that spacer. So you actually can play with the parts because you have the information. In a sense, there's a lot more emphasis and criteria on the manufacturers to produce that data in Europe. In the United States, there's a lot more voluntary. Air tightness is a voluntary, and it's all whole window. And so you don't even know the frame versus the glass. And so how do you cheat the performance of the window? You use good glass with a bad frame, and the whole window value looks great. In Europe, you use good glass with a good frame, and you have a better window because you see the values of each. So that's why I say it's more stringent testing wise, is because the criteria up front and what they have to provide to go to market is much higher.
And then that question regarding testing your Windows to the NFRC standard.
But it's extremely expensive to make and ship Windows to the test facility and then pay the test facility to run a test on a single window. The second one is we are an innovation company. So we are iterating weekly. Every time we have a project that comes in and there's a new problem that we're hit with, we're developing a solution, and we just have thousands and thousands of solutions that we pull from to solve each and every. I mean, we work across the entire United States. We work in desert, we work in high mountain, we work in urban New York City, we work on landmark, we work on coastal Seattle, Washington State, we work in San Francisco, we work in LA, we work on the coast of California, we work in Montana, Wyoming, Texas, Florida. We're literally hitting every single temp region, every building type, every economic budget type of situation. We rarely see the same building section twice.
Mm-hmm.
And so with that comes little micro tweaks to like glass and solutions and hardware, so much so that we're now like launching our steel window product line, which has high performance that's slightly better than our aluminum line. Mm-hmm. So it's another solution for the problem we'll face. Mm-hmm. We have hundreds of frames in glass when it comes to operation and glass combinations across frame types. The commitment to test all of that in NFRC is way too much, way too much money. So when it comes down to it, we have to be selective about which ones we put in through NFRC. And to be honest, I don't think NFRC is requested in a lot of places. I recently been given the spec for NYCHA pilot project in New York City, and along with it came a dictionary full, encyclopedia full of spec requirements when it came to testing with acoustic and institute testing, ASTM across the board. Like it's great that the NYCHA wants that level of criteria, which they have the right to ask, but the window that they're also asking for needs to fit within a certain budget and be of a performance level. So they're probably going to like double or more the price of the window, because somebody's going to have to commit to, if they have to commit to the full gamut of like what it is, it's a huge amount of testing. Interesting enough, all of that testing already exists, or versions of it exist in CE ISO already for that window. Mm-hmm. So if NYCHA's on the phone, NYCHA, I might suggest you start considering the ISO equivalents of the ASTM requests, because I can certainly provide you all the ISO for your requests that are ASTM or close to it. But if you want it to be retested in NFRC, AMA, and ASTM, like it's going to just drive those costs up. You're not going to get those inexpensive windows anymore. It's just going to price it out of the market, which you're seeing with some other manufacturers. So we have to sparingly spend our testing money in the right spot in order to not just double or triple the cost of our window.
So I think, yeah, so we will send everyone the recording. I would like to thank Sam for the great presentation. I'm looking forward to the steel window. That sounds like a good product. And
We have the Revit files for it. We have the Revit files. I do know that.
Okay. And I guess that's the next presentation, I would say. And we will forward to you Sam's contact information, and you can keep asking him questions. You are allowed to unmute yourself if you want to say hello.
I'll stick around too.
We're going to be around for a couple of more minutes. Thank you, everyone.
Thank you.